In this video, we will be looking at one of the most important topic as far as climatology is concerned. This topic is important for various competitive examinations, including UPSC. So, before understanding what is El Nino, we have to understand what is the normal condition which occurs and how it triggers out El Nino and La Nina condition. So, we will be looking at the normal condition first. And what is the normal condition? We have Australian coast here. This is the Australian coast, and we have the Peruvian coast here. This is South America, and we have Peruvian coast. Alright, so first of all, I would like to make you understand what is the normal situation. I just made a rough diagram to make you understand. So what happens in the normal condition is, this is the normal condition. In normal condition, first of all, we have to understand that the wind moves from high pressure to low pressure, and low pressure in this area, and we have a lot of trade winds blowing in this area, and the trade winds move in this format because there is a high pressure here and I'm moving from high pressure to low pressure. So there are a lot of trade winds here. Now this trade winds, the characteristics or nature of this trade winds triggers the condition of El Nino and La Nina. Whether it is strong or whether it is weak, this two condition proves whether there will be a situation of El Nino or there will be a situation of La Nina. But in normal condition, these trade winds are stronger. And as they are stronger, what they do? Because see, there is a lot of water here also and there is a lot of water here also. Now what happens is, this warm water, this is warm water here. This warm water in the Peruvian coast, displaced by these trade winds which are moving way stronger as it was compared before. So this water is displaced towards the Australian coast, and now this warm water is right here. This warm water is right here. Due to which there is a downwelling here. Downwelling of water. And here is the upwelling of cold water. We have to know that upwelling, there is a upwelling of cold water because beneath the ocean there is cold water because sunlight does not pertains there. Now when this cold water comes towards the shore or the coast, it brings a lot of nutrition. This upwelling of cold water brings a lot of nutritious substances, mostly that is the phytoplanktons, and this phytoplanktons attracts a lot of fishes because phytoplanktons is nothing but the food for fishes. And when this phytoplanktons come towards the shore or the coast of the Peruvian coast, a lot of fishes come there, due to which this part which is now cold water, this part is replaced, right? So this part is replaced by cold water, and as there is a lot of nutrition substance which came on the coast, it brings a lot of fishes, and that is why it becomes the best fishing ground at this time. There is a lot of fishing here. No rainfall because it is cold current here, and due to which the cold current does not attract any rainfall, due to which most of this part in this condition remains dry and a drought line condition happens. That is why in this area there is a driest desert, which is Atacama Desert, pertains here. This is a normal situation. So here is a good fishing ground, no rainfall or very less rainfall, and the warm water is replaced by cold water, and this warm water is now here. Now let us focus in this Australian part. Due to the warm water is here, there will be a convection, and due to convection there will be a formation of clouds, and there will be a lot of rainfall in this area of the Australian coast, right? So this is the part. of normal condition, and see, we are noticing that this is a cycle. Warm water being displaced here, then there is a downwelling, then there is a upwelling of cold water, and this circle or the circulation goes on. So this condition is known as, this cycle is known as Walker circulation. Walker cycle of circulation. All right. So this is the normal condition. Now we will be looking at what is El-Nino. So El-Nino is also known as blessed child. It happens to us after 2 or 7 years. We will be looking at the characteristic later on. First we have to understand what is El-Nino. So I am making a rough diagram. This is the Australian coast. This is the Peruvian coast. I am making both of the coast at the same level, but in reality they are in different latitudes and longitudes. So that is ignored here. This is for various understanding. Peruvian coast is here. Now understand, only trade winds is responsible for El-Nino La-Nina condition, right? The nature of the trade winds is responsible. We know that there is a low pressure here and the high pressure trade winds move from high pressure to low pressure. Now what happens is, when these trade winds are moving here, these are the trade winds. This trade winds get weaker. This trade winds get weaker. After that, what happens is, the cold water, due to which this cold water, Peruvian cold water, is now replaced by warm water. Alright, due to which there are various formation of clouds here now, because see, the water is now cannot be displaced here, so that there could be an upwelling because trade winds are weaker now, and the trade winds does not persist such force or strength in itself that it could move a lot of water by its own. So the Peruvian coast cold water now is being replaced by the warm water, due to which a lot of clouds being formed in the Peruvian coast and a lot of rainfall happen. And in this situation, the El-Nino situation, there is a lot of rainfall at the Peruvian coast, that there are severe floods in this situation being faced by the Peruvian. So what happens is, this is a situation, and now we have to look, if this cold water is now replaced by warm water, there is the upwelling in Australia now. This is the warm water here now. This warm water is replaced by cold water. Sorry, cold water is replaced by warm water. Now this cold water comes out here, and there is an upwelling at the Australian coast, and this cold water comes here now, due to which what happens is, there is less rainfall here, and there is a condition of drought in the Australian coast now rather than in the Peruvian coast of South America, right? So why this occurs is because of the weakening of trade winds, and how this weakening of trade winds affects the Indian monsoon. We are going to look now. Now see, here is India. I'm making a rough diagram. Here is Australia, and here is Peru, or the South America. Now this is a normal condition when trade winds are stronger, but now the trade winds are weaker. We know that how the circulation happens. We face monsoon, how the winds blow in this condition. I have made this understand in my previous video of pressure wind belts, how this wind system works. See, our Earth is moving like this, right? Whatever comes in this situation, the air is coming from this part in the southern hemisphere to the northern hemisphere of the equator. The winds are moving upwards, but our Earth is moving or rotating, right? Due to rotation, if this air wants to come here, but it deflects because the earth is also revolving with it, alright, rotating with it. So our earth moves from west to east, and when it is moving from west to east, whatever air is or wind is coming from below to upwards, it descends toward left. And in the same part, in northern hemisphere, it goes like this, right? But we have to focus on this part only. Now see, this trade winds only becomes our monsoon in this part, right? Because what happens is, when this moves in this way, it deflects in this way, right? So this is the southwest monsoon, right? Now what happens is, this southwest monsoon is being triggered by a part which is known as Mascarene High here. Mascarene High is a place, right? And now what happens is, this Mascarene High, this part, the weakening of winds, the trade winds, flowing through Mascarene High, which is responsible for southeast monsoon of India, right? So this is a southeast monsoon. So this weakening of southeast monsoon, I just said southwest, sorry, it's southeast. So southeast monsoon, this is a southeast monsoon, this becomes southwest monsoon. The southeast monsoon winds which are blowing towards India gets weakened. Why? Because this part, the Mascarene High, this is the part where persists high pressure, and this high pressure wind which is flowing from Mascarene High goes towards low pressure which is in India. But as the trade winds are weakened now, this Mascarene High pressure wind system also get weakened, and that is why it impacts our monsoon, right? So this weakening of trade winds here weakens the wind from Mascarene High, which is moving from high pressure to low pressure, and this condition, which is the condition of El Nino, brings out the worst of our monsoon, and there is a lot of drought-like condition in this situation, right? So this is how it affects our monsoon system. So this is El Nino. El Nino, the characteristics of El Nino are, it is also known as blessed child. Every 2 or 7 years, it occurs every 2 or 7 years. Warm summer current on Peruvian coast. Trade winds gets weakened, upwelling zone weakened, low pressure in Pacific Ocean, and droughts and poor rainfall in India. All right. So this is a situation of El Nino. I am summing it up again. What happens is, as there is the trade winds are weaker now, the Mascarene High part, which is the high pressure zone, and this Mascarene High, this boosts the trade winds which are coming from this direction. What happens is, these trade winds which are coming from this direction goes into this direction. Why? Because of Coriolis force, and due to which our country faces monsoon. All right. So this is the southeast trade winds, and it becomes southwest, right? So we have to make one thing understand. This boosting of this Mascarene High boosts our monsoon, but this boosting of Mascarene High depends on the stronger or weaker these trade winds are. But in this El Nino condition, the trade winds are weaker, and that is why the Mascarene High does not get any boost, and our country faces drought-like condition because there is less rainfall during El Nino condition. Now we are understanding the La Nina condition. La Nina condition is same as normal condition. What happens is, in La Nina condition, the trade winds get stronger again. The warm water, this warm water of Peruvian coast is now replaced to the Australian coast, and this is the same situation in La Nina. We can also say that it's the situation of La Nina. All right. Now, how the La Nina affects our monsoon, we have to understand this, right? So we have same Mascarene High here, and we have India here, right? This is Mascarene High, this is Australian coast, this is Peruvian coast. Now trade winds are stronger. Now due to which the winds flowing here, this is high pressure zone, this is low pressure zone, will be attracted to this low pressure, but now they are more stronger, and due to which the high pressure winds which are flowing towards from Mascarene High to India will get a boost because they are stronger now. The trade winds are stronger, due to which there will be a big boost to Indian monsoon, and that is why India will have a great monsoon at the time of La Nina. So this is the two conditions, El Nino and La Nina, which we have understand in this video. We have to make one more thing clear, that when there is a warm water, there will be a convection, and due to which there will be a rainfall, and vice versa in cold current. The Muscarine high is responsible for boosting or not boosting the monsoon. India will have monsoon as it used to have, but boosting or not boosting depends on how the wind is blowing from Muscarine high, and that boosting of Muscarine high winds depends on the trade winds which are flowing from this Australian coast. So for this video, this is all. We have understood the condition of El Nino and La Nina in it. Rest off. Thank you for watching.